Hello, hello, Bianca here. So just continuing with the intro to Trig. So we're going to be talking about how to find a side length or an angle length today using the Trig ratios that we set up the other day. So we have this question here, it's triangle QPR. So I'm going to go ahead and sketch that out. Now remember, it doesn't matter where you have your right angle, whether it's on the left-hand side or the right-hand side. That was terrible, I don't know why I did that. But here we go. We have angle R is 90 degrees, so we know angle R is this right angle right there. And then we have Q and P, and you can place them wherever. So we have Q, P, R. So they tell us that QR, or segment QR, side length, is 12. So we have here, I'm going to label that as 12. The measure of angle Q is 30 degrees, so that happens to be up at the top. And it could have been here depending on where you place it, but it does not affect anything when solving the problem. And then we want to find PR. So I'm going to place an X on PR. So that's what we're going to be looking for. Now, we do have to remember SOHCAHTOA so that we can set up our trig ratio. So I'm just going to write that out up here just again in case you forgot. SOHCAHTOA. All right. So remember, we want to label our triangle based on the angle that you're given here. So this is the angle of 30 degrees. Opposite, remember, if you can draw a dotted line across, would be O. The hypotenuse is always the longest side of the triangle, so that would be this side here, but also remember that little box in the corner for the 90-degree angle, that corner points to where it would be located, or opposite the 90 degree as well. And then we have the adjacent side, which happens to be here. Now, I always circle what I have. Now, I notice that I have this piece here, and I have this label. I don't have the value of it, but I do have the label. And I notice that it is A and O. So I look to see in SOHCAHTOA which one has an A and an O. And the one that does is the TOA piece, which happens to be tangent. So we're going to set up our trig ratio with tangent. So we have tan of the angle that we're talking about. The angle happens to be 30 degrees. And that's equal to, remember, set up the trig ratio. So tan, remember, is TOA. That's opposite over adjacent. Well, the opposite piece here is X. And then the adjacent piece here is 12. So we have that. Now, what we want to do is solve for that missing length, which is X. So we are going to cross multiply. Remember, this is division. In order to get rid of division, we do have to multiply or do the opposite. So I'm going to multiply that here. So we have 12 tan 30 degrees. And that's equal to X. And then that way we would just plug straight into the calculator. So I'm going to do that here. I'll show you on the screen in a second. So we have 12 tan 30. And you do want to make sure that you're in the correct mode. And the correct mode here is degree. So if you had reset your calculator at any point, just make sure you turn it back to degree because it automatically goes to radian. And we've got 12 tan 30, entering that in. We do want to round, let's say for this one, to the nearest tenths place, but the problem will usually tell you, and if it doesn't, you do want to provide the entire value. So here we've got X is actually equal to, when you substitute that in, if I'm doing tenths place, we've got 6.9, and we're talking about a side length, so we don't necessarily know the units here, so units, or if they were inches, you would say inches, or whatever they may be, okay? So that's the first example, solving for one of the side lengths. All right, so we have another example here. I cleaned up the board. I also moved the SOHCAHTOA over because I realized you couldn't see the beginning portion of it. It was kind of cut out. So this one I already have the triangle drawn out, and I'm looking for the hypotenuse this time. So once again, you want to go and label your side lengths based on the angle that you're given. This time I'm not given that top angle, I'm given the bottom angle. So let's go ahead and label. So we've got opposite. If you were to draw a dotted line across to the opposite side, this would be your opposite side length there. The hypotenuse is always the longest, but even though you don't know what the longest side is lengthwise, you do know that it is opposite the 90-degree angle. So remember that little box there in the corner of it points to the opposite side, and then here would be your adjacent. Now notice you are looking for the X value. So remember, I always circle the labels with the values that I either know or am looking for. And in this case, I have this one. I have this, it's a labeled X. I don't necessarily know the value of it, but I do have a label on it. So this time we have O and H. Now, if we're looking for O and H here, I'm looking for, in this case, so, or sine. That's O and H, so it's opposite over hypotenuse. So I'm going to set up that trig ratio. We've got sine of the angle, which is 37 degrees, is equal to, let me move over so you can see it, is equal to O over H. Now, the opposite piece here is 11, and then that's over the hypotenuse, which is X. Now, notice that we do have a variable in the denominator, and that's what we're going to be solving for. Now, you still have to get rid of this fraction over here, which we know is a division problem, so the opposite would be multiplication. So we're going to cross-multiply or multiply by that X on both sides, whichever way you want to think about it. So we've got X sine 37 is equal to 11. And in the previous problem, we just had plugged this piece in the calculator, and then we got our answer because we had this piece that was missing. Now it's kind of different. We are looking for what that coefficient is there. Now we need X by itself. These are connected. It's X times sine by multiplication, so we want to get rid of that sign. So I'm going to divide by sine 37 on either side. So X is equal to, and then that's what I'm going to be plugging in my calculator this time. And once again, I'll pause the video and I'll show you how to do that on the calculator, but I'm just going to plug it in for right now. So it's 11 divided by, we've got sine 37. And remember, for our purposes, we're going to be rounding to the tenths place, but, you know, it depends on what the problem's looking for. So in this case, we've got 18.3. And we're talking about a side length here. We don't necessarily know, so you can write units or just kind of leave it. So 18.3 would be the length of that hypotenuse there. Okay, so this time we're going to be solving for an angle measure as opposed to a side length. So we still start it the same way. We have a triangle here. Notice I have it in a different direction, just so I want to give you as many examples as I possibly can. So we look at this and we notice that we have theta. We don't have the angle measurement. That's what we're going to be looking for. So we still want to label the side lengths of this triangle in reference to the angle that is given, or we're looking for in this case, theta. So opposite that angle, remember, is the opposite length. The hypotenuse is always the longest, but once again, I don't necessarily know this side, so it's always just opposite the 90-degree angles. That would be this one right here, and here we have adjacent. And I want to circle what we have. So I have H, and I have O. Notice I actually have those lengths this time. So I look to see which one is H and O, which trig function, and we notice here it is so, or sine, once again. So we're going to set up our trig ratios. We've got sine of the angle, in this case theta, we don't know, is equal to the opposite side length, which is 4.2, all over the hypotenuse, which is 13.4. Now, we are looking for the angle here. So what we're going to do is we're going to hit actually a different button on your calculator, which will help us to find the angle, and that will be the inverse button. So we have sine the inverse of the fraction that we have there, which is 4.2 all over 13.4, and that's going to be equal to theta, or the angle. So I'm going to do that in my calculator right now. So we've got second sine 4.2 divided by 13.4, and remember, for our purposes, I do just want to the tenths place. So the angle here is going to be equal to 18.3, and we're talking about degrees. So that would be the measure of angle B. So you can even say angle B is equal to 18.3 degrees. Okay. Okay, so here's the last one we're going to be doing, just another example with solving for an angle. So this one says to solve for angle B. So for angle B, I'm going to put a theta there, and I want to label the triangle. Remember, OH and A. Opposite this angle is here. The hypotenuse is always opposite the 90-degree angle, and then here we've got the adjacent side. So we circle what we have. We have H, which is 5, and we have A, which is 4. A and H. We look at the SOHCAHTOA at the top of our page, and A and H notices here. That's the ca piece. So we notice that we have cosine. So this time we have cosine of the angle theta, which we don't know, which is what we're going to be solving for, is equal to adjacent over hypotenuse. The adjacent piece here is 4, but the hypotenuse is 5. Now remember, when we're looking for the angle, we want the inverse. So I'm going to write cosine with a little -1. So it's the inverse cos of 4/5 is equal to the angle which we're referring to, which you could write b or theta, whatever. And I'm going to plug it in the calculator right now. So second cos of 4/5. And then remember, for our purposes, we want to the nearest tenths place for everything today. We've got 36.9, and it's an angle, so we're talking about degrees. And once again, you could write angle B if you prefer is equal to 36.9 degrees. Okay. All right, so that's how you find side lengths or finding angles using your basic trig functions.